Hi, my name is Anika, and today my presentation is about the spectral interpretation and the structural proposals. This presentation delves into the intricate process of elucidating the structure of compound C, characterized by the molecular formula C6H12O2. The focus will be in the analytical techniques employed, including the IR and NMR spectroscopy, to determine its molecular structure accurately. So first of all, we have to figure out what is our degree of unsaturation. We have a formula to find out the degree of unsaturation is carbon multiplied by 2 plus 2 and minus the hydrogen present in the molecular formula divided by 2. After tagging the values inside in the formula, we get the du value is 1, which represent the presence of the any cyclic compound or alkyl groups. In the IR spectrum, we have these prominent 3 peaks. The first peak I saw here is the carbon-hydrogen sp3 bond peak. It's around between the 2900 and 2800 is the carbon-hydrogen sp2 peak. Another peak we have is on the 1775. It's suggestive of the carbon-oxygen double bond. Another peak we saw here is the on around the 1200, and it represents the carbon-oxygen bond. On the sides, we saw the carbon-carbon bond multiple peaks, and here we have some fingerprintings. Another is the other spectrum of a 13 carbon NMR. We saw this one downfield peak. It's around 175 ppm. It represents the carbon-oxygen double bond. And the other peaks are on the upfield is representing the tetrahedral sp3 carbons, and we have here the peak at around 50 ppm is carbon oxygen sp3, and at the 40 and 41 it's the carbon carbon sp3. Other spectrum in 1H NMR, we saw there is a multiple peaks. Here we have to deal with the 1,6 hydrogen peak, 2H, 1,1H and 1,3H. This 6H hydrogen have the double peaks and is suggestive of the presence of the equivalent methylene group because they are in the same size. And it's around 0.9 ppm. Other peak is around the 2.1 or 2.2. It's 1 hydrogen, and it's surrounded by the it is quantite peaks surrounded by 1, 2, 3, 4, and it represents the carbon hydrogen bonds. The other peak we found it on the 2.4. It's the 2H peak, and the one single and the one singlet we have on the this side at around the 3.6 ppm. It's 3 carbon hydrogen, and it's of the oxygen and methylene group. So after find out these peaks and with the degree of unsaturation, which represent the cyclic compound and alkyl compound. But here we saw that we are missing the 1600 aromatic carbon ring in the CNMR, and also missing the other at 150 peak around which represent of the aromatic ring. So we exclude this aromatic. It's not the aromatic or any cyclic compound ring. So my proposed structure for according to this graphs is the methyl pentanate. Here we have a 6 carbon attached with the methyl and the 2 oxygen atoms. Thank you for watching my video.